Welcome back. In this video, we are going to explore exponential functions. And an exponential function is a function in which the unknown is in the exponent, or the unknown is the power. So here's an example of an exponential function. F of x equals a, where a is some particular base, raised to the x power. Now there are some restrictions on exponential functions. A, our base, must be greater than 0, and it can't be equal to 1. And exponential functions have some characteristics worth noting. Okay, the graph of an exponential function will always contain the point 0, 1. And if you think about it, that will make sense, because if our x is 0, anything raised to the 0 power, our output, or y, is 1. So the graph of an exponential function will always contain the point 0, 1. Second, if a, our base, is greater than 1, the graph will rise as you read from left to right. So our graph will rise from left to right. If our base a is between 0 and 1, the graph will fall from left to right. So as we input larger and larger x's, our graph will fall. The graph of an exponential function will always approach the x-axis. You can kind of see that here in my two rough diagrams. It will always approach that x-axis, but it will never touch it, which means that the x-axis is the horizontal asymptote. And finally, the domain of an exponential function is all real numbers, and the range goes from 0 to positive infinity, which means our outputs will always be positive. So let's take a look at graphing a couple of exponential functions. Let's graph the function f of x equals 3 to the x power. Well, we can use a table of values, x and f of x, or if you will, x and y. And let's go ahead, we'll start with an easy one. When x is 0, well, our output 3 to the 0 power is 1. So when x is 0, our output y is 1. And that's consistent with our notes above. Let's try x equals 1. Well, when x is 1, we have 3 to the first power, so our output is 3. So when x is 1, our output is 3. When x is 2, we end up with 3 squared, which is 9. So x is 2, our output is 9. I'm going to correct my mistake there. And when x is 2, our output is 9, so that's 3, 5, 6, 7, 8, 9. So that's going to head way up that way. So let's take a look, let's see what happens here. We know our outputs are going to get closer and closer to the x-axis. Clearly we're going further and further away. So let's see what happens when x is negative 1, which gives us 3 to the negative first power, which is 1/3. So when we input negative 1, we output 1/3. So there you go. It's pretty easy to see what's going on here. If we input negative 2, we get 3 to the negative second power, which is 1/9. So we're getting closer and closer to the x-axis. We will connect all these with a smooth line, and we have the graph of our exponential function. Well, let's take a look at something that's a little bit more challenging. Now let's take a look at f of x equals 2 to the 4x minus 3. Our unknown x is still in the exponent, but now we have an expression as our exponent, 4x minus 3. So let's go ahead and put 0 in. Now this time we're not going to get 1 because we have 2 to the 4 times 0 minus 3. So our exponent, again, here's just the exponent part. So this becomes 2 to the negative third, which is 1 over 2 cubed, which is 1/8. So when we input 0, we output 1/8. So we're very close to the x-axis. Well, let's see what happens when we input 1. So we have 2 all raised to the 4 times 1 minus 3, which is 1. So we end up with 2 to the first power, which is 2. So when we input 1, we output 2. Let's go ahead and input 2. We input 2, we get 2 to the 4 times 2 minus 3, which is 2 to the 5th, which is 32. So when we input 2, we output 32. So we're way up here. We're way off the chart. We're into our other problem here. So our graph is going to shoot way up like that. So, well, how are we going to get more points? You know, it would be nice if we had like a nice clean output. Maybe, well, we've had 2 to the first. You know, would it be nice to have maybe 2 to the third power? You know, that would be good. So if our goal, I'm kind of working backwards here, if we want 2 to the third, or 8, well, now we have to say, kind of have to force our x value here. We want 4x minus 3 to equal 3, because we want an output of 8. So if I add 3 to both sides, we get 4x equals 6, and x equals 6/4, or 3/2. So now we know if we input 3/2, we will output 2 to the third. Okay, just put 3/2 in for x, our exponent x, and we get an output of 8. So that makes sense. 1.5, that's 2, 4, 6, 8. So we've got a point right here. So I can redraw my graph. So we've got a good idea now of what this looks like. We know this is going to head towards our x-axis, and there would be the graph of 2 to the 4x minus 3. So that concludes our introduction to exponential functions, and we will see you in class.